Okay, so this is lecture 24. This is the first example. Once again, I've run out of things to say, so there's actually no real lecture for this. This is going to be one of two example problems. And so this happens to be the hardware mod problem, so let's take a look at it. And so keep in mind, I'm not going to write down a lot of stuff for this. The solution I put in the text, and I'm just going to essentially talk you through it, tell you all I know about it, and like I said, if you have questions, it's in the book. So what I want to kind of go through is essentially my thought process in implementing these instructions, which that's what hopefully you can see what's going on also. The idea is when you see these problems, it's like, well, they're really open-ended. I really don't know what to do with them. I really have to think them out. And so I just created this one, and so it's kind of fresh on my mind. And but otherwise, it actually took me a little bit of time to think out and make sure it was a decent problem. So these problems are not at all easy or straightforward. They really require a lot of thought and certainly knowledge of the RISC-V microcontroller for sure. So anyway, so these are some special branch type instructions, and the idea of these branch type instructions is, I don't know if you can remember it, but they look just like branch instructions, but the branch instructions essentially compare two outputs of the register file. So essentially they branch based on certain characteristics of two register values. So what these instructions are doing is they're not branching on register values, they're branching on a register value and we'll say a value in memory, and the value in memory that it looks at is going to be given by the RS2. So RS2 is now going to be an address. It's not going to be a direct value. So it's going to we're going to use RS2 as an address and not connect it directly to the module. Okay, so the module we're talking about is, I'll find it here, is this thing. Okay, so right now, the branch condition generator, and that's what we're interested in because, I'll go back to this real fast. See, I mean, it has, keep going. It has the same format as a branch instruction. They look like branch instructions, so that means pretty much that I can use branch instructions. And so I'm going to use a branch type instruction. So let's look at this. So these are the branch type instructions. They have everything we have is there. They have the two fields. They have the immediate value for the jump. They have an opcode, and they have a func3 code. So the issue is that there's not enough room with this opcode. There's only two spare opcodes in the func3 here, and so I'm going to create a brand new opcode for this type of opcode, and then differentiate it with these func3 codes, very much like these instructions are done anyway. So this is going to be another B-type instruction, and it's going to use this format here, and that's going to work really nice for us. So what else? The other issue here, that works good. And so this problem becomes one of getting the right data in the right place at the right time. And if you think about it, before we just put data up into this module here, but now we have to put data, or we have to put a memory, an output from memory in there. Okay, so once we say it has to put this or that in it, this is going to need a mux on it. Okay, and the other value, one is going to be RS2, but the other one is going to be the output of memory, which is this thing. I'm trying to find a nice link to it. We'll just link it in like that. Okay, and then we're going to have to put a select in there. We'll just say select X. Okay, and that select X is of course going to be an output of this thing, of the control unit decoder, along with all the other select signals. Okay, so that's one. What we did there was we routed the data out up into this branch condition generator module, and so that's good. That works out good. And so what we're going to have here is data on both these inputs, and that works fine. And so I don't have to change. I'm pretty much sure I don't have to change anything in this module. So that's the data. The next thing I need to handle in this instruction is the address. So RS2 here represents the address. RS2, RS2, RS2. Well, RS2 is connected to data, and so that's not going to do us any good. Generally speaking, what we have here is for the address, it's coming out of the ALU here, which is for the load and store instructions. Now we're not going to use that, but we need to essentially mux this. Put a mux on this address here, and we need to get RS2 over there. So RS2 is this signal. We'll drop it down in there. Okay, and this is going to have a select. We'll just call it select Y for lack of better. Has another control signal, and that's going to come out of the decoder also with all the other select signals. And I think that looks pretty good. And once again, we routed the signals where we needed to. We didn't change this module. It's still comparing data, which means we can use all these inputs as is. We don't have to worry about that. And I think we'll call that part done. So we do need to make significant changes to the control unit decoder because now every load and store instruction has to work this mux, and every branch instruction has to work this mux. So we're going to have to change all the load and store instructions, and we're going to add these new instructions anyway. It has to recognize these new instructions. And so I think that's about it that we can say about this. But the important part is when we start talking about the state machine. Now the issue is in a normal type branch instruction, we got the data coming out of the register file immediately, but now we don't have that. What we have is an address coming out of RS2. We're going to turn that address we need to put that address into memory, but once again the memory is synchronous. So for this instruction it becomes very much like a load type instruction where we need 3 states for it. And so that essentially in the second state, very much like the load instruction, we're going to turn the read enable on. Okay, then the third state here is going to turn on the correct PC source based on whether it's going to branch or not. Okay, so that's super doable, but we have 2 ways to do this. We can reuse our write back state, which we're using for the load type instructions, which is completely valid. It's a matter of making that load state or that write back state more complex. We're going to essentially have to look to see if it's a load instruction or if it's a branch type instruction and send out the signals accordingly. But quite frankly, which is, it's super doable, but just to make the problem more interesting, I'm going to essentially add a new state to it. Instead of a write back state, we can call it I don't know, get data state. I don't know. It's essentially the third state. These instructions are going to require 3 states: fetch, execute, and get data state. And so I'm adding a new state. Okay, so that means I'm going to have to add a new state to the state machine, which is going to complicate a little bit. Not a big deal. Send out the correct signals where it needs to. Certainly one of those signals is going to be the read enable for the data. And so that's good at that point, and I think we've covered everything, and I can't think of anything. So keep in mind we added 2 muxes to this thing along with our control signals. Here are the control signals. We had to change the decoder to recognize those instructions, and certainly the state machine has to recognize those instructions also. And we added a new state arbitrarily to handle the kind of the third state required for this set of instructions. Okay, so what else do we got here? Okay, so the other thing here is just describe the changes we need to make the assembler. Assembler has to recognize these instructions. We gave it a new opcode, new func3 codes. It's going to have to recognize those, sends out the right opcodes, all the field codes and all that fancy stuff. Essentially, it has to recognize the instructions. Changes in memory requirements. So we didn't change. I don't have my picture with me. We didn't change memory, main memory. We didn't change the register file. We didn't change the program counter. I'm thinking what other memory there is in there. And we did add a new state. So the current state machine has 4 states. So if we assume we're using a minimum amount of bits to encode 4 states, that's 2 bits, and we added a new state. That makes it 5 states. Once we add 5 states, we have to go from 2 bits to 3 bits. So technically, we added another bit to the state register. So the memory increases by 1 bit. And so this modification, it'd be actually useful if my application is doing a lot of compares with data in memory. Now, it's not a big deal without these instructions, to bring it from memory into a register and do a normal type and compare, but this is going to save a little bit of time and effort, number one. Number two, it's going to be it's not going to require the use of extra registers, which could potentially be an issue. So we can pull these comparisons directly out of memory. Kind of handy. So this, like I said, this would be really handy, this E part here, really handy if the computer I'm designing needed to do a lot of comparisons with data in memory. Now, if I didn't have to do a lot of comparisons with data in memory, it would probably be easier just to use the existing instructions, which would be slightly slower, but your call on that one. Keep in mind that these instructions required 3 cycles, and now the other instructions that replace, like a normal branch type instruction and loading. Yeah, I guess that's not the case. When you have to load it into a register, I guess that requires 3 states anyway. So it's gonna save more than a single state per instruction. It's actually going to save 2 clock cycles. So after thinking about that, I need to go change the solution I have in the book there. I'm just realizing that now. So anyway, that's the deal. Fun problem. Once again, honestly, I just thought this problem up about an hour ago. I just spent, took me about 45 minutes to craft it. Took me about a half hour to type it up in the text. Okay, so I had to think about it a lot, and so you might have to think about it a lot too. No big deal. These, that's the purpose of these problems, is to get you thinking about things you can do for this. So once again, this is not the only way to do this. I'm always looking for cooler solutions. Let me know if you got them.